So this is question 1c. So it's the same procedure we did earlier on. So don't forget, we're still using the annihilator approach in trying to find the solution of this non-homogeneous system. So we're still going to do the same thing we have been doing. So we want to find the general solution, and then we know that the general solution should be of the form y equals yc plus yp. So as usual, the first step is we find yc, and we said finding yc just simply implies solving the homogeneous system y prime prime plus 4y equals 0. Now to solve this homogeneous system, we need an auxiliary equation, which is m squared plus 4m equals 0. And then on solving this, we obtain these complex numbers m equals plus or minus 2y. And then based on the fact that we have complex roots for the auxiliary equation, so that implies our yc equals c1 cosine of 2x plus c2 sine of 2x. So the next thing we want to find is yp. So we want to find yp. Now to find yp using the annihilator approach, we need an operator that is going to annihilate the right hand side. That is going to set this thing here, the functions here, to 0. So what we have on the right hand side, let me call that g of x. My g of x there is 4 cosine of x plus 3 sine of x minus 8. Now my right hand side contains two different terms, or two different families. The first one is of this family, and then the next one is of this family. So we know that based on the videos we've done so far, we know that d annihilates 8, and then for 4 cosine of x plus 3 sine of x, d squared plus 1 annihilates 4 cosine of x plus 3 sine of x. So their summation or their addition, the summation or the subtraction of the two of them is going to be, or the annihilator that sets the sum or the subtraction to 0 is just going to be the product of the two of them. So therefore d into d squared plus 1 annihilates 4 cosine of x plus 3 sine of x minus 8. It annihilates that. So since I've gotten the operator that annihilates the right hand side, I'm going to apply this operator to both sides of the original differential equation. And then when we do that, we have d into d squared plus 1 into d squared plus 4y equals, so we apply it to the other side, d squared plus 1 into, so we have 4 cosine of x plus 3 sine of x minus 8. And then since we know that this is the annihilator of the right hand side, so it sets what we have here, it sets it to 0. So we are now left with d into d squared plus 1 into d squared plus 4y equals 0. Now this is a homogeneous system, and then to solve the homogeneous system, the first thing we do is we need the auxiliary equation. Wherever you see d, you replace it with m. So you have m into m squared plus 1 into m squared plus 4 equals 0. And then on solving this, so we're going to have the roots m1 equals 0. So we have m2 and 3 to be equal to plus or minus I. That's on solving this. And then this one, which is m4 and 5, to be equal to plus or minus 2i. So this is what we have. So based on what we have, the result we have, we know that the solution is going to be of this form: y equals c1 plus c2 sine of x plus c3 sine of x, and then plus c4 sine of 2x plus c5, so we can call this cosine of 2x. So having gotten the solution of the newly formed homogeneous system, the next step we want to do is recognize yc, the complementary function. So I'm looking for the term that contains cosine of 2x and sine of 2x, just a multiple of them. So and that term is, So we have cosine of 2x here, we have sine of 2x here. So this is going to be my yc. So that implies that the remaining one, that's the remaining terms, is going to be yp. So I already have an assumed form for my yp now. So I'm going to let my yp be, so like I said, we might just not use the c1, c2, c3. You might just use a new constant, and then if you like, you could use the c1, c2, and c3, anyone that is very comfortable with you. But I'm trying to run away from using subscript so I do not confuse whoever that's going to be watching the video. So I could call my c1, let me call it a, plus my c2, I call it b sine of x, and then my c3, let me call that c. So this should be cosine of x, sorry, this is cosine of x. So c cosine of x. So then we take the derivative of that, because we need to substitute it into the original differential equation here. So I need to find the second derivative. I already have y. So to find the second derivative, I start by finding the first derivative. So this goes to 0. Then you have b cosine of x minus c sine of x. And then the second derivative of this is going to be minus b sine of x minus c cosine of x. So that's what we have. So the next thing is we substitute yp prime. So that's what we have here, and what we have here into the differential equation there. And when we do that, what we would have is 4a plus 3c cosine of x plus 3b sine of x equals 4 cosine of x plus 3 sine of x minus 8. So the next thing we want to do is we want to compare coefficients. So on comparing coefficients, what we observe is the constant we have here is 4a, and the constant we have here is negative 8. So we can say 4a equals minus 8. So the other thing you observe is the coefficient of cosine of x is 3c, and the coefficient here is 4. So we'd say 3c equals 4. And then lastly, we'll also observe that the coefficient of sine of x here is 3b, and the coefficient here is 3. So that implies that 3b equals so that should be 3. So this should be 3 here. And then when we solve that, what we would have is, so this is going to give us, so for a we have minus 8 all over 4. So that's what we have there. So my a is going to be negative 2. So my c is 4 all over 3. And then my b equals 1. So I've gotten my a, my c, and my b. So I'm going to substitute them into here, here, and here. So what we have now as a final solution for yp equals my a, which is minus 2, plus sine of x, that's 1 times sine of x, and then plus 4 over 3 cosine of x. So since I've gotten my yc, so therefore the general solution is going to be y equals yc. So my yc from above is c1 cosine of 2x plus c2 sine of 2x, then plus my yp. I've decided to put it in bracket. It's not necessary to put it in bracket, but I've decided to put it in bracket so that you clearly see what I'm doing. Plus sine of x plus 4 all over 3 cosine of x. So this is the general solution of the original non-homogeneous differential equation that we're given.